I build computers and circuits, so let's just go through some stuff. I've already shown that to send signals through our body from the brain to the limbs, like how it's explained right now, would break Volta's law. So I've shown how like the autonomic nervous system, which doctors will say it can synapses there, it can synapses there. No, if you look at the way in which all of these ganglia are set up, this is a fluid control system. You can see where the fluid slows down, and it can decide based on the heart rate, which we know the autonomic nervous system controls, that it would be able to literally decide based on the way it pumps, which way and everything goes to synapses. So how's another thing? We know that when we do the blind spot test, it'll just paint in whatever's there. And we know we have the motor and the sensory homunculi. So what kind of simulation, what kind of model, what kind of computer would just have its own little model of itself sitting inside of itself? Like your computer doesn't have a computer in it. But if you were a controller and you couldn't handle the amount of data that was coming in, which we know you can't, because if you see a flashing light, instead of it literally flashing on and off randomly, which would happen with our Nyquist frequency, which we know we have, and even if like you can't change the acceleration rate of a fluid instantaneously, so that's going to give us a minimum sample rate. So when something like on the TV goes from 60 hertz to 120 to 240, and it looks like it's going faster, right? But it's not actually faster. So when the flashing LED is like when you're recording a car tire and it's going in different directions like that, instead it looks brighter or darker. The way colors show up, the fact that this is a crystal lattice, right? We know it's mostly empty air, but we're reacting with it. So what if, I don't know, like for instance, the moon, like they say, crashed into us? What kind of bow shock would that have? How wide is that? And I think people forget that bow shock isn't just how fast you're going. How big you are means that the air it doesn't just go down and then around a little bit, right? It's going down, and then the whole way of like the whole width of the moon, it's trying to shift around. So the whole time that's happening, it's crashing into more, right? And if you look at, I think it's the second law maybe of thermodynamics, that stuff right there, it has no cap on it. It'll get hotter and hotter and hotter and hotter. And the moon itself is huge, right? But like if you look at it, it doesn't look like there was really much damage. So then what happens when that bow shock hits the ocean? Which we know the ocean's gonna pull up to meet the moon. And when the bow shock meets an incompressible fluid, just like when the little tectonic plate shifts and you'll get 500-mile-an-hour waves, if the moon hits, with this giant bow shock, which makes it even wider, and you have just plasma, that's got positive ions there. So then now you've got these positive ions, and you've got the ocean, and when you look at how when a fluid moves, it's going to cause electrolysis, because if it moves quickly, what's going to happen is you're going to create a potential difference by moving of the ions really quickly, so you're going to get a voltage. And what happens when plasma just gets smashed into water that is a serious amount of energy. If you look at, like, I think it's two positive charges, like 1 meter apart, it's something like 2 tons of force pushing them apart. If you were to have like 2 things of gold or whatever, and you let go of one, and they were positive, like they were both too positive, they would just explode. It would just shoot back up, right? How'd the moon get back up there and it's like undamaged? I think it bounced off the ocean, and I think that bow shock fused with whatever there, like, right? Similar to like how a salt can get dissolved into a fluid, or gas can get dissolved into a fluid, and all of a sudden, like, it's invisible to us. But for whatever reason, it's still there. Its mass is still there. Its volume is still there. It's still interacting with things as a gas or as a solid. It's still interacting, but we don't see it. I think we build our model of the world based on what we interact with. We're some sort of a dissolve into the air, whatever. And so when we can like close our eye and see something just get painted away, when we know their sample rate is too slow to pick up this detail, to interact with the environment the way it is, we know that just the amount of information in like Beethoven, if you look at Beethoven's Moonlight Sonata and you go to the third movement, you put in those numbers, just like, oh yeah, that's way too much. It's way too much. So then what's going on? It's all about your thought. What you think you can do really is all you are. It's all you can do. If you think you can't do something, you will absolutely never do it. Because why would you Now, if you look at the connection, right, the pseudo-unipolar neuron, it's connected between what the spine, the autonomic, which controls your sex organs, it controls all your limbs, and now it's connected to the brain. And they're like, oh yeah, it's unmyelinated, it's uninsulated. It's not insulation. I've already shown this on my page. It's a capacitor. I can show you how it works as a capacitor through the theory, and just I have two capacitors. I have a capacitor, an electrolytic capacitor next to it. It's opened up, and it's like, it's the same design, except you see how the curve. All right, so then I've shown that it's basically, you wouldn't put a capacitor across an analog input, would you? And that's what's connected to our brain. And they say they know it's two directional, the pseudo unipolar, stupid name. We know that it's two directional, and we know it works like an analog. And when you think you know you have synapses going on, which is going to cause a positive charge, there's a lot of force. And so it's just literally down there feeling it all up. I've also shown on my page how like all of these signals, I can just touch all of these signals and read them right back out through my hand with my little thing. The reason is I'm not using 70s equipment. I'm not using an MRI machine that was designed with these giant radio coils that are like 30 minutes to try and get a signal. Like I'm just putting a signal in and getting a signal back out with technology that literally, like, you haven't even, go find a piece of 20-year-old equipment, right? If you can find that, then tell me why something that was designed in the 70s is in a hospital and they're using it. When you look at it, it's using radio waves. Those things are huge. No wonder why it's missing all the time. It's just averaging. It's like, stay still. Stay very, very still. Because the coils are designed to run on a CPU from the 70s. I'm gonna stop giving you guys stuff. That's enough.